So this demo is the loop. So we have something that it resembles a small roller coaster. Let's say you have this rail that loops around, and we have this object. What we want to do is to have it roll, and then roll through there and come back on this side. So to do that, we'll release it at some height, and we can use conservation of energy to try to figure out at what height should we release this. So we want this ball to be here and rolling through. So you might say, okay, at that point, we want it to get there. So if we start at that same height, then you might think, okay, there's some potential energy there that you were trying to get to convert to kinetic energy. So that might be the first guess. So let's see what happens. Let's try to get approximately that height and release the ball. So as you can see, that doesn't make it through, right? So our assumption of having enough potential energy that converts to kinetic energy, we want a little bit more energy, right? Because we don't want it to get to here and kind of lose energy and fall over. So we need some extra energy for it to get here and still have kinetic energy to travel all the way through the loop. So there's a point here where it will work. So let's take a moment to guess where along this rail will it work. So the first option we have was the same height as this rail here, so approximately there. And so let's say we can either put it there, or let's say somewhere here, right? So we have several options here, and let's see if you can think about where should you put this ball for it to actually roll through all the way. So let's try this point here, and let's go and see if that works. As you can see, it makes it through. Maybe it jumped a little bit, so maybe go a little bit higher. As you can see, that went all the way through. So it started with some potential energy, and it had enough energy to go all the way through the loop. So that's the loop.